should be.
Yep.
So I'll get myself removed from the stream here. So we got the video starting right now. So a little bit over 1 minute before we start.
Good deal. Demo's up. Where did it go? How many? Do you have any metrics on how many people are showing up?
Actually, I don't have them.
Are they available though? You know why I'm asking.
They will be.
Good.
Yeah, they definitely will be, and I guess we will be sharing. Yeah.
Yeah.
Okay, great. Because I would also like to have them.
Yeah.
Yeah.
You can ask that.
Us as well. So we're all
about the numbers.
Forward to what the numbers. Yeah.
We're all MVPs. Except Nick.
Yep, indeed.
So you work for Microsoft, so you're not eligible then.
I don't work for Microsoft. No, I'm a freelance.
Yeah.
Okay.
I didn't think you did.
I'm going offline now. Okay. Have a good session.
Hey.
Thank you.
Hey, good evening, everyone, and thank you for staying track too. And at the moment, we have our last session. I'm extremely happy and grateful to have Ginger Grant from the US coming over. She's going to talk all cool stuff about Azure Data Machine Learning. Well, I just give the stage to her, and I'm going to be amazed myself for sure.
All right, thank you very much, Chris. Really happy to be part of Azure Community Day, last session of the day. And I'm going to be talking about data-driven decision-making with machine learning. So Azure Machine Learning, if you've ever messed with it, it's really changed over the years. And now it's giving even more features. And I'm going to show you some of those, looking at how you can use AutoML. While I'm showing it to you here today in Azure Machine Learning, you can use these same concepts in Azure Synapse, or you can include it in .NET. So kind of cool stuff we got going on here. A little bit about me. My name is Ginger Grant. I am a Microsoft MVP and a Microsoft certified trainer. I am on Twitter way too much at Desert Isle SQL. In addition to being a Microsoft certified trainer, I'm also a trainer at Data Camp. And if you want to get a hold of me, there's my contact information. Okay, so a little bit about what we're going to be talking about today is what Azure Machine Learning does. We're going to see how you can bring your own code into it. We're going to take a look at AutoML, and then we're going to be talking about how you can test and deploy it. So with a 10,000-foot level, what you do with Azure is first you're going to be registering your data. So this is one of the strengths of Azure Machine Learning. When you do machine learning, a big question is, where does this data come from that you want to use in your environment? And so with machine learning, you register the data set so there's no questions what the data needs to have. And then you go ahead and you train your models. So you're going to be looking at everything that you need to do to use machine learning algorithms and training and test your models, and then evaluate them, figure out which one's best, because every time you code something in machine learning, you're not done. You need to evaluate whether or not you've created something that can perform well. And then you're going to deploy models. And so we're going to be talking about how we can kind of work on improving some of this training and evaluation, also some of the features when it comes to deploying. So with Azure ML, you've got a workspace, since it seems like many Azure components today include a workspace. This workspace is where you do all of your working in the environment, including, of course, doing things in notebooks. So one thing that Azure Machine Learning has, which is pretty common now with many of the Azure components, is you've got your own clusters. So your code is separate from your the machine that you're running it on. And that's great, because if you decide that the machine is too slow, you can just put in a new one, make something that goes faster. If you are familiar with the machine learning studio product that was previous, Azure ML Studio, there are some components that still live in that today. So we'll take a look at those, and we'll take a look at the designer as well. Well, enough talking. Let's actually take a look at what a new environment looks like and how you can create one. So this is my Azure Machine Learning environment. I'll show you how to create one here. It's pretty easy to do. I'm going to show you what I call the cooking school model, in that I just showed you what it was like to be finished. Now I'm going to show you what it's like to create one. So I'm going to go ahead and create a machine learning resource here. And up at the top here for machine learning. And there's just a couple of things that you will want to know when you're doing this. I'm going to go ahead and create a new group here. And in my workspace, I'll just give it a standard workspace name. You want to make sure that you select a location where your data is, because like everything in Azure, if you have to move across locations, then you will be charged for it. And the most important thing to know here is this edition information. So you have two options, basic and enterprise. And yes, enterprise has everything. But I can tell you the reason that you're probably going to want to use enterprise, and why I would recommend selecting it pretty much no matter what, because I do believe you can justify the cost, is that only with enterprise do you have the ability to do auto machine learning, and you do not have that capability with basic. So for that reason, I go ahead and always select that. If I hit create here, in approximately 5 to 10 minutes, I would have my Azure Machine Learning workspace environment. But who wants to bore you with all that? We'll go back to my existing workspace and show you what you get when you go into Azure. So what we get here is we get a Machine Learning Studio experience. You have your compute assets listed here, and you can also create them within the Azure Workspace. And it's going to load my compute resources here in a little bit. And I have taken off. I've got one workspace here, and I've got it stopped. This works similar to Databricks, for those of you who are familiar with that environment. When you are not using your compute, you can stop it. And so mine is stopped. I'm going to go ahead and start that up. So if we look here in the overview while this is starting, we see here that we've got a couple of good bits of documentation here. This documentation is actually pretty helpful, so you do want to check it out. But I'm also going to just launch into the studio. And this is what you see when you are using Azure Machine Learning. So you get your workspace that you're involved with. So what I have here is I've got the ability to do notebooks. And similar environment like you have seen in every other notebook that's on Azure. Oh, by the way, you might want, if you have any other notebooks in notebooks at azure.com, you might want to move them over before October because it's going away. But I've got them organized here, got a number of different environments set up here where I can look at all of my different notebooks that I've got created. Go ahead and load something up here. And notice here, this is where I've got my kernel connected. So this is where I would select my compute once it's finished loading. And I can run any my language here. I'm presently running Python. In addition to that, we've got the automated ML, which we'll look at here in a little while, which was going to create machine learning for you. And then something that I do want to take some time to review now is the designer. So for those of you who are familiar with Studio at AzureML.net, this is the child to that. So that was where it started. This contains all of the similar components in that environment. So if you are familiar with that environment and you like that environment, you can create models using a drag and drop method to create machine learning. And you can, of course, run these with your selected compute target. And I'm using the default. And this will create a machine learning solution for you. Here, what I'm doing is I'm taking some data. I'm selecting some columns in that data set. I'm cleaning my listening data. and then splitting the data into trust and training and running a linear regression algorithm on it and scoring and evaluating it. So it's a really great way to introduce yourself to some of the machine learning concepts. And while this looks like it might be, just like demo code, it's not. I can create a module with this that I can deploy to any other Azure component. Like I could run this in Azure Data Factory, or I could call it from standalone, say within SQL Server. And so this creates code that's pretty useful and very easy to create. Highly recommend taking a look at this if you're not at all familiar with machine learning. And the best thing about it is it's got some pre-built samples so that you can take a look at how you can do, say, binary classification with Python. And it gives you some working code that you can play with and use on your own. So just a great way to get started with using machine learning if you're not familiar with the concepts. Of course, you do have your ability to write your own code, which is what I showed you earlier, but they also have this getting started area for it as well. Okay. So the next thing I wanted to talk about is a feature that I think that is really useful in Azure Machine Learning is the automated machine learning part. And so automated machine learning is where the algorithms that you are using in your model are selected by the tool. So it goes through and looks at, and you tell it what you're trying to do, and then it will iteratively determine which algorithms would be a possible candidate for creating a usable solution for that tool, and then going ahead and creating them. So one nice thing about what the tool does as well is it will also do hyperparameter tuning for you. So it's will also tune your algorithms as well. So you might want to use automation learning when you want it to train your model for you, and you're in a hurry and you just want to specify some target metrics and let it go. And then the service iterates through machine learning algorithms paired with different feature selections that you pick, or each iteration produces a model with a score. And then the higher the score, the higher the model is considered to fit your data. So you configure what makes a good model. So how this works is that you give it the type of hyperparameter ranges that you're interested in. You tell it how you want to optimize it, and you give it an early termination policy. Let's say you're doing a binary classification, and you say, hey, if the accuracy reaches 97%, you can stop because that's good for me. You can set a budget. How long do you want to take to come up with an optimal solution? Or how many times do you want to try? You can compute the number of parallel ones and tell it to go for 6 hours or any combination thereof. So then it's going to create, using a training script and training data, and input that into automated ML, and then it'll spit out a quality model for you. It will tell you all of the different models that it tried, what the settings were for each iteration, and then give you the best result given the conditions that you have set up. So it lets you pick it picks the algorithms and hyperparameters and generates a model. But one thing you can do with it is you can tell it, hey, I know that I don't want to use naive Bayes because it won't work for this situation, or you can exclude certain algorithms that won't work. If you want to further customize the model, you can, and let's say that you're creating a more complex model, and this is just one of the steps that you think that you are going to be employing, you can download it so you can further customize it. And this helps domain experts improve how quickly they can deploy a model because it runs through all the possible tests for you, improve productivity. So to automatically train the model, we're gonna be defining the sets for the experiment, and then attaching our data and modifying the settings that control the process, and then submit the experiment for model tuning. And after we submit the experiment, we're going to go through it's going to go through and process the algorithms and parameter settings, and then choose the best fit model by optimizing the accuracy metric that you specify. So you've got total control over what it's doing here, yet it's going to generate some really neat code for you. So how it works is first you identify the type of problem to be solved. Unfortunately, it doesn't do everything just quite yet, but you can use it for classification, forecasting, or for regression. So you can specify the source and the format of the labeled training, like NumPy arrays or pandas data frames, and you can configure the compute target for model training. So you can use your local computer, you can use Azure Machine Learning computes, remote VMs, or you could even choose to have your compute be an Azure Databricks Spark cluster, should you prefer. So you can use any one of those elements as your compute engine for automated machine learning. So you can then tune the parameters that determine the iterations over different models, hyperparameter settings, or what metrics to use to get the best model. And you can configure it with the Machine Learning Studio or the SDK. And one thing I wanted to remember, if you didn't pick Enterprise when you created your machine learning workspace, you can't do this. So you wanted to make sure that this is why you select the Enterprise workspace, so that you'll have this feature. So during training, what it's going to do is it's going to create a number of these parallel pipelines and try different algorithms and parameters and stop once it hits the exit criteria defined in the experiment. So you can inspect the logged run information containing those metrics, and it produces a Python serialized object, commonly known as a pickle file, that contains the model and the data pre-processing. And while the model building is automated, you can also look at what the important or relevant features are to the generated model. And you can see that on the leaderboard, which model won and what all the relevant scores for that model are. So let's take a look at doing machine learning. And I'm going to show you how to do it in the automated fashion here first. So going back to machine learning here, we're going to click on the automated preview. And we have two different ways of doing this. So we have the automated way where it's a click and drag function, and then we'll have doing the code. Unfortunately, the demo that I have set up for you took about an hour and a half to run. So I have created a little video, shows how I did all of it, and I cut out the slow part so that I can be able to finish it in this session. But I wanted to show you the new features that are available. So if I wanted to create one using the UI, what I would do is I would click on this new and then create a new automated run. And these are my registered data sets that I already have created. One of the things that I won't have time to talk about here, but one of the cool things that you can do with Azure ML is you can have it analyze your data sets automatically to compute drift. So if your data sets change over time, you can be notified of the drift that is occurring and the very different composition of your data, so that you know that you probably need to take a look at your machine learning algorithm. But we're going to take a look here at my data set here, which is going to be for diabetes. And I'll go ahead and click on next. And this is going to show you that my data here in a second. I'm going to go ahead and create a new experiment. And I'm going to call this Analyze Data. And what this is going to have in it, my data sets has whether or not somebody is a diabetic or not, based on some of their medical information. So the target column is where I already have an answer. So newsflash, this is going to be a classification algorithm, and it's going to be a binary algorithm because there's only two possible answers here: if you are a diabetic or if you are not a diabetic. So those are the two different options that I'm picking from here. And so I have my compute target here. I could have created a new compute. And again, compute is just the computer that this is running on. So I have the ability to run on whatever type machine that I choose to run my machine learning on. You've got a number of different options when it comes to compute, including high-end servers that run CUDAs using GPUs if you want to go that route. Naturally, this is not that big of a cluster. So I'm going to go ahead and say next. And it has examined my data and has determined that, this is probably going to be classification. And it is correct. This is a classification algorithm. So I could enable deep learning. I'm not going to. And these are the other two options that I have available to me. And I have additional configuration settings that I can set here. So here I can say that I want to block a certain algorithm. And this is the part that I told you about, that I could say, don't run naive Bayes safe. I do not want to use it. And under primary metrics for a classification algorithm, I've got a number of different options here. I've selected accuracy, but I could also look at area under the curve weighted, norm macro recall, or the average precision score, which is weighted, or the precision score, which is weighted. So I've got some different components that I can choose in addition to accuracy for which is the most important metric to me, which is very useful because, not accuracy is not, believe it or not, the most important selection every single time for classification. People want options, and so this gives them to you. Exit criteria. So I can set a number of different criteria. I can set the number of hours. So, run for 3 hours, and then as many possible algorithms as you can possibly think of in 3 hours, go. Or I can look at a metric score threshold. So I could do 0.97. So if my accuracy, it reaches 0.97, then it will stop. Under validation, I can do auto, or I can have some kind of cross-fold validation, Monte Carlo or train validation, and concurrency. So the number of concurrent iterations it's going to run. Now, generally speaking, you want different concurrency. You can change this so that it computes a lot faster and looks at how much resources you're using. That's really what this is, the setting that this is going to do. And I wouldn't want to do 3 hours. We're just going to limit this to 1. And I'm going to go ahead and say save. And then I'm going to go ahead and say finish. And it's creating a run, and we will have the results in an hour, or when it gets to 97%, whichever finishes first. And so it's in the process of running now on this compute target. So while we're looking here at how I could do this in an automated fashion, let me show you how I could do something similar, but using Python code instead. So I'm going to go ahead and run this little video that I have created, just showing you the ways that we can go ahead and do this. So this is an example of showing you how you can do compute using a Python code rather than running through the automated fashion that I showed you now. So what I'm going to do is I'm going to go ahead and go into a Jupyter notebook. And in my Jupyter notebook, I'm going to go ahead and select one that I have configured with the Python code that I need for this. I'm going to go ahead and open that up. And this notebook is from within my machine learning environment. I'm not popping out to anywhere else. And so I'm just here. What the first step that I'm going to be doing is I'm going to be, well, first I'm going to clear everything out. So I got a fresh new run here. But I'm going to test connecting to my workspace. And I want to make sure that my workspace is indeed ready and I'm good to go. So now that everything's cleared out, what I'm going to do is I'm going to just test to make sure that my workspace is configured and its workspace is ready to go. My computes are already ready and everything else. The next thing that I'm going to do is I'm going to upload the diabetes data if I don't have it to make sure, and I'm going to replace it if it's there. So that way that I'll have fresh new data that I can analyze. And here I'm going to register my data set. So what I'm doing is I'm taking my tabular data because it's comma delimited, and I'm going to split my data into training and validation with a 70-30 split. And then when this is compute is complete, then it's going to go ahead and print data ready. So it's uploaded the files here. And then when it's complete, it'll had and created my test and training split. And now it says data ready. So now I have my data loaded. I've got it split into groups. And now what I'm going to do is I'm going to configure automated machine learning. So what I'm going to go ahead and do is these are the configurations that I'm going to use in my model. So here I've said that I wanted this to be a classification. I'm using local compute target, local being Azure Compute. My training data, which I just created in the previous step, is called train DS, and the validation is called test DS. And I just created those in the previous environment. I'm just setting them here. My label column, again, similar to the auto version, is called diabetic, which is the name of that column. What I have decided to do here is I've decided to run 6 iterations. So I'm going to try 6 times to find the best machine learning algorithm that I could possibly use. I'm going to use 4 concurrent iterations to do my analysis. Well, let's make it, stick it at 6 here. I'll just change that to 8. And for concurrent iterations, it's going to do that 4 at a time. And then I'm going to go ahead and say run. So I've got 8 iterations, and then 4 of them are going to be concurrent. And now that's ready to go. So what I'm going to do now is I am going to submit my experiment. So I've given it what parameters that I want to use. Now I'm going to just basically tell it to go ahead and run it. So I'm going to go ahead and run this model. So all of this code is using the AutoML SDK. While I am showing it here in Python, it also runs in .NET. So you are not limited, and in R. So I'm going to go ahead and submit my experiment here. And then when it's submitting, it's going to, while it's running, we can take a look at what's going on and take a look at how the models, what the models are doing. So in my experiments pane here, I'm just going to take a look at what's going on so I can get an idea of how the compute is working. So I'm going to go into my experiment. And this is my diabetes AutoML experiment. And we'll go ahead and refresh it to see the latest. And go ahead and load that up. And here we see that how it's running. And we can see that this is the run number 16. I've done this several times before. And it's taking a look at the runs that are going on here. Now remember, I didn't specify a time. I said do 8 iterations and 4 of them concurrently. So I can tell you this ran for well over an hour. And so here I'm done. And these are my 8 iterations, counting from 0. And you can look here at the different algorithms that were tried and the run preprocessor. So I did light GBM, stack ensemble, voting ensemble, light GBM, random forest, SGD. And then these are the scores that it calculated. And the abscalers, basically, those are my hyperparameters that I have created. So then it shows like how many seconds each one took to complete on its own. So we can take a look at how that performed. And we can see, the solutions of it, looking at the precision recall, the area under the rock, the gain curve, the lift curve, the calibration curve. And we have all the different possible scores that we could possibly think of. Matthews correlation, AOC Macro, F1 score, anything that we could really think of that we could want on a binary classification algorithm is contained here. But if we go back to our code here, but so we've got like all this information here, but also in our code, what it's going to show us is it's going to show us kind of a summary of how much it ran, how long it took, and which one is the best. So here we see the first one, funny enough, was the best. And it had the score of 0.9905. And that is max upscaler using LightGBM. So it shows us all the iterations that we're running, but in code, it shows us the best observed score. And this will show you the best observed so far, so it'll keep on updating while it's running. Of course, I was lazy, so I didn't bore you with all this and waited until it was done. So you can see all the iterations here in your code that it ran. And this is basically kind of an abridged version of looking at your machine learning workspace. And we can see the scores for the other models. When we hover over them, we can see how the other models did. So in case we couldn't figure it out by this code here, which shows us the best, we have code here that shows us the best performing model. And so we can we can do this so that it's completely automatic, trying to do a DevOps method of doing this. So I can just click on the this code here, and it'll tell me what the best run is. And so I'll get the output of, run 0. So it'll show me that information. And it shows me the information. And here it shows me all the other possible scores. And it shows me the ID. So I can take a look at it in the Azure ML Workspace as well. And it shows me all the scores that I could possibly get with it. So I've got a good indication of why it was the best, even on metrics that I wasn't even evaluating. And here I can do the name steps for the model. And then so I can register that model. But here it's just showing me which steps were the best. And so the ABScaler was the pre-processing steps, and LightGBM classifier was the algorithm that contained the best results for this. So now, once I found that this is the best algorithm for my data and the best hyperparameter settings, then I can register my model. And once my model is registered, then I could do a whole bunch of deployment things with it, should I wish to do so. Once the model is registered, I could create a Kubernetes cluster that I could deploy it with, or I could say deploy it in Azure Data Factory. I've got a number of different options of what I can do with my registered model. Registered models will also show within Azure Machine Learning how many times they have run and how long each run took. So it gives you some more information. It also creates a pickle file for me so that I can make it easy to configure it if I'm loading this to somewhere else. So this is how I would do it in code. Let's go back and take a look and see how the AutoML is running as well. So we'll take a look at see what we have for models here. And we've got one model that is completed now. So this 1 minute, 18 seconds thing is kind of misleading. And we can take a look at what it's looking at. You'll notice that this is showing us the same types of things that we looked at in the code version. It runs the same thing, and we can look at all the metrics possible for this. But it's when we're done, we'll have the same ability to register this model as we did the code that we created in Python. But it's busy running through all of the possible algorithms that it's going to select and give us some explanation previews when it's done. And this is what you get when you're doing it live. But unfortunately, as you see, this is going to take a while. So I did show you the sped up version in a video. So a little bit about some of the benefits for auto machine learning. For one, even if you are a trained data scientist that really knows your stuff, it just takes time to run through all the possible iterations of things that you could possibly use. So I know this is no substitute for having somebody who really knows what they're doing, because we're only talking about 3 different kinds of algorithms here: classification, regression, and time series. And yes, these are the simpler versions of the model. But that being said, you can tune your hyperparameters and pick the best algorithm for your data. So I've messed around with this too. It's not just always going to pick the same model. It's going to take a look at the kinds of information that you have in your data. It's going to select different elements based on its analysis of what will provide the best model. And then it is going to use the criteria that you selected. If I had selected, something other than accuracy, then I might get, if I'm looking at F1 score, I might get a different model that's selected for me if I'm looking at classification. So it's doing this selecting for me, and it'll run through as many algorithms as I let it do. I mean, how many hours do you have? This, of course, gets into the question, well, which is more expensive, Azure time or data scientist time? I'm not here to answer that question, but I don't think Azure's that expensive, just saying. And then you can use this to for people who, if you're in an environment where there aren't a whole lot of people who know a lot about machine learning, because you have the capability of doing machine learning without knowing a whole lot about it. And you know that you are going to have the best algorithm and the best parameters because it's picked it for you, and you've run through a number of possible options and determined which is your best one. And you know what? If you wanted to do this yourself, you could go through it anyway. So this automates the exploration processes, helps you use your resources more efficiently, optimize the model for the desired outcome. It can control your resource budget because you can say, I want it to run for an hour. I want it to run 8 times. However you want it to run, you can pick it. And you can apply it to different models and different learning domains. You can pick whichever training frameworks that you want. And this allows you to visualize the possible configurations in one place. So if you were kind of wondering, hey, what if I use different hyperparameters? What kind of a result would I get? You have the ability to look at the code that was created, take a look at what was created, and then look at the outcome. So naturally, if I'm not using classification, I would get different results because regression doesn't use the same analysis, uses root mean square error. But whatever you're using, it will give you the appropriate results and visualizing it in one place. So once you've got this created, and oh, by the way, the code that I showed you is straight up Python code using the Azure ML SDK. And you're not limited to using that SDK only in Azure ML. You could also use the same code in Azure Synapse. And I could do that in Azure Synapse, and it would run then on Spark clusters to get the results. So what this provides you the ability to do is create and containerize your model. So once you've got your workspace created, you've got your image processed and load your feature, you add your classifiers and you save your model. Once you've got your model saved in Azure ML and you've got the data set registered, it's really easy to deploy it. What you can do is you can convert the model using deployed using Onyx, and you can create a Docker image. And once you have that Docker image created, you can then choose to deploy anywhere you want. You could put it on field programmable gateways if you felt like it. You've got a lot of flexibility for where the model can be deployed. So, from Azure Machine Learning Studio, you're going to select your different compute instances because you have control over that too. One thing that's really nice about the framework is it'll show you every single time the model is run, so you can take a look at that. The notebook will display the URL if you are doing the model, and you can test that local compute instance to see how the deployment is going to work for you, to give you a little test of things that you can do with it. So you can, when you're deploying an Azure Machine Learning model as a web service, it creates a REST API, and you can send data to that API and get the prediction returned to the model. And you can create that and use it for web services and call it with C#, Go, Java, Python, whatever you want. You create the web service when you deploy to the container instances. You can use Kubernetes if you want to, and you create images from the model and scoring files. If the authentication is enabled, you can also use the Get SDK to use authentication keys or tokens so that you can have the model be very securely executed. So what I showed you in this whirlwind tour, since I only had 45 minutes, is what Azure Machine Learning does, how you can use your own code, or also how you can use the interface. We looked at AutoML. We looked at how it does its various testing, and we talked a little bit about how you can deploy. And before we close off here, let me take a look at refreshing and seeing how many models that we've got so far. We're up to run number 5 now. So we've got more models that it's running. So it's still doing its thing. So we can see the different models that are available to us and see all of the scores that we want to see up here for our auto machine learning that is running as we speak. So with that, I was wondering if there are any questions that I could answer that have cropped up during the session.
So thanks, Ginger, for a great session. Just checking the chat window. We don't have any questions so far.
Okay.
But maybe I can ask you one.
Sure.
So AutoML, looking really nice and a great solution for many different reasons if you're not into ML that deep and don't know all the algorithms. Do you have any view on, because basically you depend on the different algorithms to be available through AutoML. Do you have a view on, is that list of algorithms, is that continuously being updated? How does that work?
I haven't heard about any updates made to it recently, but I will say that this is a kind of feature that many tools are creating now, which makes Microsoft competitive with a lot of other tools. This is getting to be a big thing in many tools, and they use a pretty long list of a lot of algorithms that you would use for this kind of work. So while I haven't seen any updates, it's kind of new. So I expect that there will be some in the future, but I'm not aware of any at this point.
Okay, cool, thanks. Okay, cool. If there's any questions, people can reach out to you, I guess, on Twitter.
Yes.
And other social media.
Right. I'll go back to my other screen here. Yes, happy to answer questions. If Twitter's, like I said, best way to get a hold of me, but I have a contact page screen, or at my email at gingergrant@desertisle.com, desertisle.com. But yeah, cool. It's Twitter's probably the best way of getting a hold of me.
Okay. Thanks a lot. Okay, thanks a lot for this great session.
Well, thanks to you. I really appreciate the fact that went to all this effort to put it on, and I know this is the last session of the day, and I appreciate how much hard work that you put into it, and it's really late for you. So thanks again for putting together. I enjoyed watching some of the sessions earlier today.
Okay, thanks a lot for all the credits, and I think all the credits go to not just us; it's the entire team that's sitting behind the scenes, but also all the speakers, all the people that have been watching throughout the day, and that will be watching through all the recordings. So it's been a pleasure to do this for the community.
Yeah, really glad you did it.
Thank you.
You're welcome.
Thank you.
For the people still watching here, so this is the last session of track number 2. We still have a number of sessions going on in track 1, and I think also in track 4. So feel free to join those tracks for more amazing content. And afterwards, if there's a session that you missed and that you really wanted to watch, just come back to this site and just select your session in the schedule, and you will be directed to the appropriate YouTube link. With that, thanks a lot, and hope to see you soon at a future event.
Yes,
thanks once again,
so.
Ginger.
Super.
Thank you. Bye-bye.
Bye.
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 For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.